Howdy, howdy. This is Mr. Potter. What I want to do with the picture class for one last thing is I want to do something called Steganography. Now, Steganography is the idea of hiding data within other data. And what we're going to be doing here is we're actually going to be hiding a message in a picture. So I want to go look at my files real quick. There's two pictures that I want to look at. One is the beach scene, which we've been dealing with throughout this lab. But there's also a message down here that says, meet me at 3 p.m. You know, very surreptitious, very sinister. And what I want to do is I want to try and find some way to encode this message into this beach. So we're going to talk about how to do this. So the first thing I want to do is I want to talk about the idea of, you know, we've been manipulating color throughout. So I'm going to go ahead and start a method, which we're going to say public void encode. And we're just going to encode a message. But the idea here is that I'm going to take all of the rows and columns, all the pixels in this image, and just tweak red a little bit. So I'm going to create an array of pixels like we've done before. So a matrix of pixels called pixels gets this dot get pixels 2D, and then for pixel array row in our matrix pixels, and for pixel p in row, I'm going to do this. I'm going to say if p.getRed mod2 is not equal to 0. In other words, I'm going to check and see if the red value of the pixel is odd. And if it's odd, then I'm going to go ahead and p.setRed to p.getRed -1. So in other words, if it's odd, I'm going to move it down to the next lowest even number. So 1 would become 0, 63 would become 62, and 255, which would be full intensity red, will be moved down to 254. And so what I've done here is just a real simple, I'm just adjusting the red slightly. And I want to go ahead and test this. So I'm going to jump over here and I'm going to write a test encode method. Just because I want to see what's happening here. So I'm going to have public, let me go ahead and space this correctly, public static void test encode. And so we're going to open braces. And we're going to do picture beach gets new picture beach.jpg, close parentheses m, and then we're going to beach.explore beach.explore. Then we're going to beach.encode, and then we're going to beach.explore. And so what this is going to do is it's just going to go through every pixel in this picture, and if it's an odd red channel, we're going to make it an even red channel. And I just want to show you how negligent this appears. It's not going to change the picture at all. So there's our old. Let me go ahead and comment this out. We don't want to test Snowmoon anymore. We just want to test Encode. So I'm going to get rid of the and decode, because we are going to have to talk about how to break this message out of its little box. So if we run this, we're going to draw two pictures here. And just looking at them side by side, there really isn't a great difference between them. I mean, over here, I've got a pixel 117 that's red at 254.34. If I go to 254 and 34 over here, notice that it's 116, 145, 146. And the difference in these, cyan type colors, these dark cyans, there's really no difference at all. Even if I go down here and there's a gray, a nice tan color at 440. At 440. And at 372, it looks like it's the same tan color. It's just one red lower. So this is setting up for our issue. So now what I want to do is I want to talk about actually getting the message from the message file. So I need to create a new picture. So I'm going to say picture MSG gets new picture, and I'm going to put in here msg.jpg. So this is going to be the message that we're going to try and encode. And we're going to try and encode this in our original picture. So again, I'm going to do pixels array, and we'll call this MSG pixels, gets MSG dot get pixels 2D. Keep in mind that I'm in the picture class. I'm in picture.java. And so I can either talk about this where I'm the picture itself, in which case it's the beach picture, or this picture object that I've created within the picture class, which is MSG. And I can go through and check its pixels as well. But if I want to check pixels for two different things, I really need to iterate through. So I really need a row and a column to compare. So instead of doing a for each loop like we did before, I'm going to say for, and I'm going to say int row gets 0, row is less than beach, or MSG dot length row plus plus, and then do the same thing for column. So for int call gets 0, call is less than MSG sub 0 dot length call plus plus. And then I want to know if this is part of my message. Now let me go back here to our file that we were looking at. Keep in mind that our message is a white background with black text. Black text that says meet me at 3 p.m. Remember that white is 255s in all of our channels, and black is 0, the absence of light image. So it should be zeros in all of our channels. So what I'm going to do is I'm going to say if, and I'm going to have to get the color from MSG pixels. So if MSG pixels sub row sub call dot get color, that's going to get a color, and I want to know if it equals and I want to ask the color class for its color dot black, and if that's true, then that means that I'm in the message. I need to make red odd. So now we've got this point where we made all of the reds have an even value. But if I'm at my message, I now want to say, oh, we're going to move you back to being odd if you're part of the message. So if we're part of the message, if message pixel sub row sub call dot get color dot equals color dot black, then I want to take this pixel. So pixels sub row sub call I want to set red to pixels sub row subcall dot get red plus 1. So in other words, I want to get the red and bump it up 1. This is going to make it that odd value of red. And so that means that wherever my message is, I want to show that that's part of the message. So this is going to be my encode method. I'm going to compile this real quick just to make sure I don't have any egregious errors. There's just one error in here I need to fix. MSG.length. What is it having an issue with? So what's my error? MSG pixels.length. Let's fix that then. Pixels. Silly mistakes. But that should take care of that. And then in my picture tester, I don't want to just look at beach. I also want to look at the message. So picture MSG gets new picture MSG.jpg, and then I also want to do MSG.explore. So I'm actually going to have 3 pictures that are open. And so I'll see all 3 of the pictures, but of course the main reason I'm doing this is because I want to make sure that the appropriate things have been changed. So all of these should be even. And of course, if I click around, I'm noticing that I've got even stuff. The thing is, I want to go to where my message would be. So let me get over here someplace where I get a nice 0. There was a nice 0 at 228 and 93. So if I go to 228 and 93, notice that my red has been changed to 1. Something else you may also have noticed is that in this picture, some of these things are black, and I say black in quotation marks. 8888 is actually a very, very, very dark shade of gray, but it is not true black. So I actually need to make sure that I'm within a certain color distance for black, because part of what JPEG images do is that they do lose some data by compression, and the act of compression means these colors aren't going to be true white and true black. If I click in the middle of this 0, I'm not going to get true white. So I'm going to get 241, 241, 241 instead of 255, 255, 255. So I do need to make one small tweak. I'm going to go ahead and close these off real quick. And I'm going to change this picture so that I don't want to know if it's equal to black. I just want to know if the get distance. So I actually want to get the distance between this. So I need to look back at how we did get distance before. I'm going to search for get distance without caps locks. So I'm going to check for get distance. We did do get distance, didn't we? Distance. The one are we talking about the color distance? So we had our edge detection. We had this idea of color distance. That was what we were doing. So we're doing right pixel dot color distance from the main color. I want to know if the pixel dot color distance from color dot black is within a certain threshold. So that's actually what we're going to check. So instead of saying if it's equal to black, I want to take this pixel and I want to check its color distance. So we're going to get rid of this and do color distance for color dot black. And if we're less than, say, 10 away, in other words, we're at 333 or we're at 444, something very close to true black, then it's going to take care of this for us. So we should get a little bit better indication of where we have odd pixels. So let's run this one more time. Remember, this is going to show me 3 images. The last image is going to be my message. But now I should be able to click on some of these other letters, like this T here, and that 229 and 56. If I go to 229 and 56, then that's odd. If I increase the row, that's just moving down the T, I should be odd. So I do get some more odds in there. So that's important. So the last thing I want to do is I want to take this image that we've just created, where we've changed the reds to even and then changed some of them back to odds. I want to take this image and I want to write it. So what I'm going to do is I'm going to do this dot, and I want to write. Remember that we talked about how to write to a file earlier by using this dot write in our collage. So I'm going to take this dot write, but I'm going to call this encoded dot JPEG. So we're going to put this in quotes like a file name. And the thing that you'll notice is that in our folder we don't have a file here called encoded yet. We're going to be creating that file. So now we'll compile this. We will run this. And that, of course, does all of our message stuff that we're expecting. But now if I look at my file, I will find an encoded .jpg. And this encoded will actually have the message as part of its system. So that is my picture tester. So now what I need to do, this is testing encode, and we actually don't need this message anymore. So what I can do now is public static void test decode. And then what we'll do is we'll do picture encoded gets new picture encoded .jpg, and then we'll do encoded .explore, and then encoded .decode, and then encoded .explore. And so the idea is, now that we've done what we've done to this, how do we decode? And the answer is, the way that we decode is we're going to go through and look for odd pixels, just like we did before. But if we find an odd pixel, we're not going to set its red channel. We're going to make the whole thing black. Otherwise, we're going to make the whole thing white. So we're going to do public void decode, and we're going to create a matrix of pixels, just like we did before. So pixels gets this dot get pixels 2D, and then I want to go through the array as well. So for pixel array row in pixels, and for pixel p in pixels, and then I want to say that if p dot get color dot equals, and actually I just want to know if it's red is that, so I actually just need to get red. Mod 2 is equal to 1, so in other words, if it's odd, it's part of the code. And so if it's part of the code, then I want to make it black. So I want to say p dot set color to color dot black. Else, I want to do p dot set color to color dot white. And then what I should be able to do at this point is I should be able to say this dot right, and we'll call this decode dot JPEG. So in other words, this should save this as a decoded message. So let's compile this, make sure that works without any errors. Go compile, and incompatible types. Let's fix that real quick. For pixel p and pixels, it's not pixels, it's in the row. We've only done that 7 times so far. We'll compile this test, and we'll run it and see what this does. This should load the encoded image, show it what it looks like before, and we should get a message out of it, but we don't. Oh, because I'm not testing it. So we've tested encodes, now we need to test decode. So let's run this. And we end up with this garbage. So what's happening is that I am still ending up with some odd pixels, even though I shouldn't have odd pixels. And so what I'm going to have to do is, again, this is part of the fact that we're saving this as a JPEG. This JPEG is actually showing it as an issue. I really need to do this as a bitmap. And the problem with doing this as a bitmap is that it's going to make a huge file. Right now, if I look at the encoded.jpg that we've got here, let me go back to my my folder, if I can go back to my desktop and my PictureLab and my images. If I look at this encoded, this encoded is 60 kilobytes. If I create an encoded .bitmap, it's going to be a huge file. So let's go ahead and compile this, and we'll go back to our picture tester, and we're actually going to redo this test encode again. So let's change this back to encode. And if I compile this and run it, it's going to create that image. And notice all these values are even out here. It's only when we get towards the message in here that I end up with some odd values. You can see the occasional odd value here as I go through. I find some. It's hard to find the message. It's hidden. That's the whole idea about steganography, is that this is supposed to be relatively hidden. But now notice I've got this encoded bitmap, and it's 900 kilobytes. It's almost a megabyte, where this encoded JPEG is 60 kilobytes. But saving it as a bitmap means that it's going to preserve all of those pixel values for me. So now what I want to do is I want to load from encoded.bitmap. We're going to compile this. Actually, we're going to change this back to Decode. And we're going to run this. And this should give us the proper thing that we're expecting. And notice that I've got this. Meet me at 3 p.m. Now, the reason that this looks kind of grayish and mottled and stuff is because, again, our original message was a JPEG. And so our original message did not have true black and true white in it. But it's enough for me to actually see the message here that we've got. And if I go to my image, let me go back to my desktop and my PictureLab and my images. If I go to my decoded, notice that my decoded is a JPEG, which is 7 kilobytes. This is a message that's 7 kilobytes. So I'm able to get the proper result. The thing I had to do, though, is I had to remember that JPEGs, because of their compression, are going to incorporate some extra data, and so some of those pixels end up getting tweaked. I really need to go to a bitmap, which, although it's a raw data type, it's a raw file type, and so the pictures end up being very, very huge file-wise. It does preserve that. So, just wanted to talk about that. I want to try one experiment real quick. I want to see what happens if I change this to PNG. PNG stands for Portable Network Graphic, and what a PNG does is that it does the same idea of storing a file, but it's not supposed to change the pixels. And I'm just curious if it actually goes about doing that. So I'm going to run it once with this test encode, saving it as a PNG, and then I want to see if I load this as a PNG, do I end up with the same issue? So we'll go ahead and stop that. We'll go to Decode, and we'll run this. And I'm curious if we get the same. Yeah. The thing is, if I do this as a portable network graphic, then that's going to get the same modeled effect, which is okay. And if I go back to that file and I take a look at that file on my desktop. PictureLab images. If I look at encoded.png, which is not that one, that's our JPEG. There's our portable network graphic. It's kind of halfway between. I mean, it's not the 900 kilobytes that the bitmap was, but it's not the 64 kilobytes that JPEG was. So it is a way to look at it, and of course it's going to get us the same message. Meet me at 3 p.m. The idea about steganography is that you can hide data in plain sight. I can upload this to an image loading file server, or I can email a picture to someone, and people would not have any clue that there was a message in there. And of course, I just decided to use the red channel. Someone else could decide to use the blue channel or the green channel or some combination of the channels. And the idea of tweaking one amount in any color channel isn't going to create an obvious difference in the image. Our eyes just can't see to that level of detail. So that's steganography in a nutshell. I hope you've enjoyed this. This is one of the applications that we can do. So if you're ever caught behind enemy lines, this is a way you can get some information out, as long as the people you're sending the information to know how you're going to do it. So once again, this is Mr. Potter. Thank you for watching. Have a great